Alright, so I'm going to do 2 or 3 videos. We'll see, it might go up to 4. I'm going to start out doing what we did in class. So I started out with the standard setup for tabs, units, and font. Go sticking with Arial 12, black 12 point. That should be very visible on screen in a video. So I'm going to re-sequence a few things. First thing I want to do is get my constants. So gravitational constant and standard atmospheric pressure. Then I'm going to put in we're going to start with the flow rate for in English units and convert that. Clear up some extra space here. So English units, because that's what the problem was. I'm also going to put a couple diagrams in a minute here. Let me go ahead and put the rest of these in and we'll talk about it. So we got density, and we're picking that up from T. Actually, I want to put T next to V dot. So I'll put it up here under P. All right. Because these two, we're going to change at some point, and so we'll want to comment them out and or make them, put them in an if not statement. So we got the temperature, pressure, density, dynamic viscosity, vapor pressure, length of the pipe, the height. This one, as I mentioned in the second class, we don't need it in feet. 0 feet and 0 meters are the same, so we can put it in like that. Makes life easier, or not. And then we also had the K values and sigma K and alpha. So let me copy and paste those in. Okay, K1 through 5. Sum of K1 through 5, and you don't have to put in every individual. And you could put K1 in brackets, comma, K2 in brackets, comma, and so on. So K1 in bracket, or K1, comma, K2, comma, K3, comma, K4, comma, K5, comma. I believe is another way to do that. This is easier. That's why we use the array as opposed to um, an underscore or just K1 without any other annotation. So at this point, we should be able to calculate. Everything is good. So mine offers suggested units. You can set ease up to do that. If you do that though, in the ease on Citrix, it won't retain it. So if you want to do that, whenever you go in, you can go in, set your preferences, and go to, I believe it's options, and set units automatically when possible. Check these various things for being selected. Normally I don't include a sum in a parametric table, but you can if you like. So that's worth spending some time to look at. You can also set it up to autosave if you like. I don't generally do that. I probably should. And these are other characteristics that you can put in. Anyway, so you'll just have blanks here. So I can just double click on it and it's suggested a unit. That unit looks good. cubic meters per second looks good. Kilograms per cubic meter looks good. Kilograms per meter second looks good. And all our units are good. So far, so good. Next, we want to put in our formula for NPSHA. Actually, before I do that, let me create a diagram window, and I want to put in a couple of diagrams. Okay, so I've got a diagram window. I'm actually going to make it a little bit bigger. I'm going to put some extra stuff on it. So we're going to put the diagram for the system and the diagram for the plots that they did. Okay, so here we got NPSH curves. So we're going to be creating plots with these curves on them, including the NPSH. The other thing we want to do is put in a child window. So a child window, click on that icon, new child diagram window. We're going to call this NPSH R. And actually, that's pump curves, which includes NPSHR. And we want to be able to access other tabs from this window. So like the main diagram, you'll see. So we've got this now, and we can go to the main diagram window or the pump curves diagram window, and now we just need to copy in the pump curves. So you can actually copy these right out of the PowerPoints also and paste them in. So I copied it, I pasted it. It didn't give me a dialog box here because I'm copying and pasting it from another EES program, so it already recognizes what format it's in. So what I did, and we'll talk about this later, I plotted these at 100, 200, up to 800 GPM intersections with required NPSH to produce this curve myself. So back to where we were. So let's get this so we've got down here where we can grab it. Big enough so that everything's going to show up on one screen. And we don't need the diagram window for now, so we'll go ahead and put that away. Daughter window, put that away. And now we need to put so we're going to create that NPSH R curve eventually. But first we got to go back and complete our programming here. So I'll copy the equation in. And notice it, so let me undo that. And it went where the insertion point was. Unfortunately, I tapped a touchpad and it moved my cursor. So NPSHA, we went through that in class. That's the formula. And then we've got NPSHA English because those plots are in English format. Let me shrink this down. There we go. And so for the plots, we need to have, we'll just convert it. But we can't make a plot on an alternate value. We're going to make it on the main value, I believe. So this is just an easier way to keep track of that. He keeps changing, improving, so it may be that that's been changed since the last time I tried to do that. I might check that out later. In the meantime, so we've got P and PV, we know, pressure and pressure is atmospheric pressure, vapor pressure, saturation pressure at our current temperature. Density we figured out. G is acceleration due to gravity. I made it so that it's a variable, so it shows up in our formatted equations window as a variable, not a number. Z1 minus C2, head loss, alpha minus 1, so on. So we don't know the head loss. So we need to put the equation in for that and solve for that. And so F times L over D, sig plus the sum of the K's, that quantity times V squared over 2G. We don't know F, we know L, we know D, we know sigma K. We don't know V squared, but we can find it, and we know G. So let's go ahead and put in the Colebrook equation and what we need to find V. So Colebrook equation will find F for us, and we can also find V, and we'll need to find Reynolds number, so copy all of that and paste it in. So the Colebrook equation, open that up a little bit for clarity. Colebrook equation, Reynolds number, rho VD over mu, because we have rho and mu. We could find nu if we wanted to and just do VD over nu. Since we have engineering equations solved, we can just look it up the way we did with mu. We could say, instead of viscosity, we could say nu equals kinematic viscosity, water, T equals T, P equals P. Same deal. Either way. Velocity is volumetric flow rate divided by area. Area equals pi times d squared over 4. And if we look at the formatted equations, everything looks nice. V dot over A. Again, the parentheses to force everything here into the numerator. Notice our Greek letters show up as the appropriate Greek letters when we spell them out. If you spell them out uppercase, they show up as a capital. So we should have, where's our sigma? Should be, there we go, sigma. So uppercase. If we typed it out in lowercase, it would be this the small lowercase sigma, which is not appropriate for summation. So we've got that. And what else do we need? So we should be able to calculate. Let's check it out. Here, this will tell us 27 equations, 27 variables, no syntax errors, okay. We're going to have some unit issues because there's no units listed for area or for the total head loss, or that's, I think, it for what units are missing. Let's go ahead and solve it. And this is what happens the first time you try to solve it if you haven't set up your variable information. F is normally going to be between 0 and like 0.1, 0.08. So we're going to say, we'll guess 0.05 is our guess value. So that's where it's going to start, because this is an iterative process for the Colebrook equation. And we're going to say 0. 0 for the lower bound, and 0.1 we'll say is the upper bound. Click OK. Now it should solve no problem because it's not trying to find a square root of a negative number. NPSH English is not feet per meter, it's just feet. And Reynolds number is unitless. Why is it doing that? Let's see. Head loss meters, cubic meters per second. No, that's meters per second. I'll have to come back to that. So that's meters though, head loss, that's fine. Meters per second. And now maybe I can delete that. Okay, so that worked. And what do we have? Potential unit problems. A is meter squared, that's correct. And what unit problems do we have? Variable V. Okay. In our NPSH calculation, there is a problem, and I believe I know what it is. I do. Okay, let's see. So we've got NPSH should be meters. Okay. Meters per second squared. GPM. Meters cubed per second. Oh, there we go. Not sure where that came from. That's, I typed in meters per 6 instead of meters per second. Meters per second. And we're good. Okay. So that brings us to the point where we've got NPSH calculated. That's where we finished in class. I'm going to stop here, about 16, 17 minutes.